I love that countdown like we're about to be actors on a set. 3, 2, 1, action. All right, here we go. All right, so considering our string and what we just talked about. All right, look at these two. We watched this video, so ignore that at the top. So this is horizontal, like I said, and this is vertical, like I mentioned already as well. Okay, so look at this picture of the horizontal. See how this distance here is A? So that is going from the center out to the outer edge, the farthest edge of the ellipse. And that point that's on the ellipse is called the vertex. Okay, well over here you have another vertex then. So I have another vertex over there. And this distance would be A as well. Okay, then this distance from center to that shorter edge is called B. So this would be B as well. Okay, the distance to the focus we call C. So I would have a C on both sides. That's how far it is from the center to the focus, and we'll fill all this in below in just a second. But watch this. If I had that string, remember the string was 2A, because we said the string would really reach all the way across the widest width of the ellipse, then if I stopped the string when it was up here at the top, like that, then this would be A, and that would also be A. Okay, now I have a right triangle here. Right triangle right there. Okay, this is going to blow your mind. You're not going to like it. Look at that right triangle and let's set up Pythagorean theorem. I would have B squared plus C squared equals A squared. Oh, Lordy, that like defies everything we've ever written. But considering what we're calling A, B, and C, that's our Pythagorean theorem right there. So it's called the Pythagorean relation of an ellipse. So if you know B and C and you need to find A, we use this. If you know A and C and need to find B, we use this. Okay, so notice I mentioned the vertex and the vertex, one on each side here. But then at the very top, this is called the covertex. So that's the shorter distance across. So I have a covertex there and a covertex there. And those are going to be the 4 points that we actually connect to draw the ellipse. Kind of like we made 4 points yesterday to draw the circle. We'll plot those 4 points and sketch the ellipse. Of course, we have our center point there. This distance all the way across, the widest, is called the major axis because it's bigger. And then this distance across the shorter direction is called the minor axis. And I think I got all the terms in there. And then, of course, it's all the same thing over here if it's vertical. It's just the vertices are the ones up and down, and the co-vertices are the ones side to side. The vertex is always in the longest direction. The co-vertex is in the shorter direction. Okay, so let's go down here and fill in some things. The vertices are how far away from the center. Looking at what I've labeled everything, I kind of drew over this one, so it might be easier to look at this one. What's that distance called from center to vertex? A. Vertices are A units away from the center, so that's what A represents. A is the distance from vertex to center. The co-vertices are B units away from the center. So B is the distance from center to co-vertex. The length of the major axis. Okay, so if this is A and this is A, how long is the whole thing? 2A. If this is B and this is B, then the distance of the whole minor axis is 2B. And that distance that we use, I drew it in blue over here, from center to focus, we call C. And then we have a formula to find C or find A or find B. One of them, the Pythagorean relationship, is B squared plus C squared equals A squared. Okay, so look for 1 second on this formula sheet. Look at the bottom here. It says formula for C. C squared equals A squared minus B squared. That's not what I just wrote. But are they the same? Are those two equations the same? Yeah. If I solve that equation for C squared, then I would have to subtract B squared over. So yeah, those are the same thing. You can write it either way. Eccentricity, let me go ahead and mention that. That describes how circular or elongated the ellipse is. The more circular, the closer to 1 this fraction is. The farther from 1, then the more flat or squished the ellipse is. Okay? All right, turn the page. We're going to talk about how to graph these things, and they're really quite easy to graph. But notice the equation here. That's kind of messy looking, like we have fractions, it's equal to 1. Here is the standard form. So standard form, that's what we want. We want fractions. Notice there are quantities squared that look like the circle. That x minus h squared, y minus k squared, we had that with the circle. But now they're over fractions, and then the whole thing is equal to 1. Every single time for standard form, we're going to set it equal to 1. Okay, so this is how we go about, let me show you how to graph it first, and then we'll fill in all this good stuff over here. Okay, in an ellipse, a squared, remember, is your longest distance. So which one of these denominators would be a squared? This is a, this is going to be a horizontal. I'll tell you how I knew that in just a second. This is going to be a squared in the denominator and b squared in the denominator. So if a squared is 64, what is a? 8. If b squared is 25, what is b? 5. That tells us how far out from the center we're going in each direction. Okay, where's my center? Is there anything subtracted from the x and the y? Just like with the circle, if we just have x squared, y squared, then the center is 0, 0. Okay, so center, 0, 0. And I'll go ahead and fill that in over here as well. Okay, so we're going to, just like the circle, we're going to plot the center point. And just like the circle, the center point is critical, but it's not actually on the ellipse. Okay, in the A direction, I'm going to go 8 units. Notice that this big denominator is under x. So that's telling me go in the x direction 8 units. If I say x direction, what do you think I mean? Right and left. Okay, so I'm going to go right 8 and left 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the 25 is under the y squared. So that's telling me, hey, this 5, because the square root of 25 is 5, is going in the y direction. Well, y direction goes up and down. So from the center, I'm going up 5 and down 5. And those are the 4 points that we're going to connect for our ellipse. So try to connect them so they're not a diamond. Try to curve into them and draw the ellipse. Okay, so that's our ellipse. Now let's go ahead and label over here what we know. Remember, the vertices are the ones farthest from the center. So what is that ordered pair right there? 8, 0. And then I have one over here on the left, and it is negative 8, 0. Okay, the co-vertices are the ones not so far. So that's these 2 points that I connected. And remember, I went up 5 and down 5, so that's 0, 5 at the top and 0, negative 5 at the bottom. Okay, so then the only other thing I need to know is what are these little key points that are so important, like with breaking up the kidney stone and in the whispering gallery? What are those focus points? Where are they located? that's where we pull in this equation right here. So c squared equals a squared minus b squared. Okay, that means that c squared is 64 minus 25. A squared is your big denominator, b squared is your little denominator. So c squared equals, what is 64 minus 25? 49 or 39? 39? Okay, well what is c then? The square root of 39. Can that be simplified? I don't think so, so we're just going to leave it. Now, the focus are always in the longest direction. So in this case, it's a horizontal. The focus are going left and right, just like the vertices do. So if I go right, square root of 39, where am I? What ordered pair? Square root of 39, 0. How much is square root of 39? Between 6 and 7. And how did you know that? It's actually a little bit closer to 6, right? Okay, so what I'm going to do is graph it just by going a little more than 6. 1, 2, 3, 4, 5, 6, and a little bit more. And I'm just going to put a little F there for focus. And then 1, 2, 3, 4, 5, 6, and a little bit more. And another F for focus. But what are those ordered pairs? Well, I went right square root of 39, so it's just square root of 39, 0. And I went left square root of 39, so it's negative square root of 39, 0. Are we okay with those? All right, so the a squared and the b squared, notice up here it says the larger denominator gives you a. Okay, so a squared is largest denominator. A squared is always bigger than b squared. Okay, so wherever that largest denominator is, that's going to tell you if it's vertical or horizontal. My biggest denominator was under x. That means I'm going to go farther in the x direction, therefore it's horizontal. Okay, the next one is the opposite. The biggest denominator is under y. Therefore, this one will be a vertical ellipse because biggest denominator is under y. So a squared is your largest denominator, so a squared is 36. That means that a is 6. The other denominator is b squared. B squared is 9, therefore b is 3. Okay, where's the center on this one? Same way that we did with the circle. 5, negative 2. Because it is still being subtracted like it was with the circle. So you're basically taking the opposite of that number. I'll look at that and I say, oh, that's a negative 5. So the center will be positive 5, comma, negative 2. Okay, so we're going to graph it and then we'll find the foci. Okay, I'm going to plot the center point. Go over 5 and down 2. There's the center. From the center, I am going an a distance of 6. But remember that 36 was under the y term. So that means y direction 6 units. Up 6, down 6. Okay, b is 3, but that number came from under the x's. X's go left and right. So from the center, I'll go right 3 and left 3. This one's going to be more narrow, isn't it? And you can see this is going to be vertical, so we'll connect them. So that's our graph. Now for the vertices and co-vertices, I'm going to go back to my graph and just pick out those ordered pairs. So the vertices are the ones farthest. So what is that ordered pair there? 1, 2, 3, 4, 5. 1, 2, 3, 4. 5, 4. Okay, what is this ordered pair down here? Well, I went over 5, down 2, 3, 4, 5, 6, 7, 8. 5, negative 8. Now stop me if you have a question. Okay, the co-vertices are the ones that are closer in. So this ordered pair over here is 6, 7, 8, negative 2. And 2, negative 2. I'm just naming those points. Is everybody good so far? Okay, to figure out where the foci are, now they're going to be up and down, same as the longest direction of the ellipse, but I have to find that c value again. So I'm going to use c squared equals a squared minus b squared. Remember, a squared is the bigger denominator. 36 minus 9. What is 36 minus 9? 27. So c is the square root of 27. Now that can be simplified to 3 square root of 3. I don't care if you simplify it or not. You want to just leave it? Okay, let's be lazy and just leave it. How much is that then? Little more than 5. Okay, so from the center, I'm going to go up a little more than 5. 1, 2, 3, 4, 5. And down 1, 2, 3, 4, 5 and a little bit. Okay, now this is a tricky question. What are those ordered pairs? Not as easy as the one above to tell. Okay, so this is what we do. Didn't we start from the center point? From the center point, I went up square root of 27 and down square root of 27. Okay, so the x-coordinate here is still 5, isn't it? Same as the center point. So this is what we do. Seems kind of lazy, but it's actually the most accurate way to do it. I started at negative 2, and then I went up and down square root of 27. And that counts for both order pairs. I went negative 2 plus 27. That got me to one order pair. The next one I went from negative 2 down square root of 27, and that got me to the other one. And that's the exact y-coordinate without using a decimal. Question? What if I had went left and right? Then I would add and subtract it to the x-coordinate, but leave the y. Okay, but because I went up and down, it just changes the y value from the center point. Are we okay? No questions? All right, let's do this third one. Will this be vertical or horizontal? Vertical. How do you know? 81 is under y. 81 is our biggest denominator. So what is a squared? 81. What is a? 9. Okay, what is b squared? 4. So what is b? 2. Okay, where is the center of this little thing? Okay, 7 left, so that's negative 7, 0. Is everybody okay with that? Negative 7, 0? Just like with the circle, you take the opposite of that number in the parentheses. Okay, so next thing I'm going to graph it. I go and I plot the center point. 1, 2, 3, 4, 5, 6, 7. Okay, how am I going to move 9 units? Up and down or left and right? Up and down, because that 81 was under y. Y-axis goes up and down. So good thing we didn't go left because there's not room. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9. Okay, 2 came from the smaller denominator, which is under the x. X-axis goes left and right. So I'm going left 2, right 2. This is a really skinny one. Connect them. There's our graph. Vertices are these 2 points that are farthest away. So that is -7, 9. And -7, -9. Sometimes you'll see people write it this way. -7 ± 9. Instead of writing 2 ordered pairs, one with 9, one with negative, you can also write it as that one ordered pair if you want. Okay, covertices are the ones that are really closer in. So that would be -5, 0. And -9, 0. And then we find the foci. All right, you guys find C and I'll find C. Check up here when you get it. Okay, are we okay with square root 77? How much is that? Almost 9. Okay, so between 8 and 9. Okay, so I'm going to go, it's going to be right up there. Real close to the vertices. Okay, but what are those ordered pairs? Well, we started at the center. The x-coordinate was -7. These have the same x-coordinate, but they have different y-coordinates. So I went 0 plus or minus square root of 77. So you can write it that way if you want. Like that. Or you could just do -7 square root 77, -7 negative square root 77. You got it. -7 plus or minus square root 77. There's 3 options there. Yep. Or. Are we good? Any questions? I feel like there should be some. Okay. Let's do one more of these. I don't think we need to do 2 more, do you? Does one of them look harder to you? I think one of them does look harder. Which one would you say is harder? Did you say 5? Why? I agree. I totally agree. I think 5 is harder. Why? They're not perfect squares. Yeah, so let's do 5. Okay, what is a squared? The big denominator, 75. Okay, so a is square root of 75. Now that can be simplified. I don't care if you simplify them or not. I'll go ahead and simplify. That's 25 times 3. So that's 5 square root of 3. You can leave it square at 75 if you want. Okay, b squared is the smaller denominator, which is 20. So b is square root of 20. That can also be simplified. I don't care if you simplify it, but if we do, that's 4 times 5. So that becomes 2 square root of 5. Now, if I'm thinking of how far is this, I'd rather think of square root of 75. That's easier to think, okay, it's a little bit more than whatever. Okay, where's my center point? 0, -4, nice. Okay, let's plot that. 1, 2, 3, 4. Okay, so let's talk about how much is square root of 75. If you need to use your calculator, use it, but I bet you can think it through. Between 8 and 9, because 8 squared is 64, 9 squared is 81. So we'll just go, a little more than 8. In which direction? Left and right. 1, 2, 3, 4, 5, 6, 7, 8, a little more. 1, 2, 3, 4, 5, 6, 7, 8, a little more. Okay, square root of 20 is between what and what? 4 and 5. So we're going to go a little more than 4, up and down because that's under the y. So 1, 2, 3, 4, and some more. 1, 2, 3, 4, a little bit more. Okay, so this is horizontal. That shouldn't be a surprise to us because that biggest denominator was under the x. Connect your points. Okay, vertices. That's these two that we went left and right to. So the x-coordinate is just square root of 75 and negative square root of 75, and then we drop down to negative 4. So we went right, square root 75. Do y'all want to do plus or minus square root 75? Negative 4? Does that throw you off, or are you okay with that? Right and left, square root of 74, and down to negative 4. Or list them both. Square root 75, negative 4, negative square root 75, negative 4. Okay, covertices. Well, this x-coordinate is 0, but I went up square root of 20 from the center, which was at negative 4. So I'm going to say, all right, I started at negative 4, but then I went up and down square root of 20. But the x is still 0. Yes. All righty. Foci. Let's find our c squared. C squared equals a squared minus b squared. So c squared is 75 minus 20, which is 45? No, I cannot subtract 55. So c is square root of 55. Okay, to plot that foci, I'm going to go left and right. How much? More than 7. A little more than 7. 1, 2, 3, 4, 5, 6, 7. Okay, so what is that ordered pair? Well, it has a y of negative 4. What I changed was the x, but I went from 0. So I could say it's 0 plus or minus square root 55, comma, negative 4. Or I can just do plus or minus square root 55, negative 4. You okay with those? Are you sure? Okay, I don't know that we're going to get finished with these. We'll do a few more. That video ate some time. Okay. Now we're going to take something, this is in general form, and we're going to put these in standard form. Okay, so standard form is the fractions, and they're equal to 1. Can you guess what I'm going to have to do to get a 1 over here? I have 2 ways to get 1 over here. What are they? I could subtract 224. But then I'd have to subtract 224 over here, and that's going to give me 3 terms. What's the other way to make this a 1? What can I do to 220? What? Divide by 225. That's it. Whatever this number is, I'm going to make it 1 by dividing by itself. But we have to divide everything by 225. Okay, now the good news is these usually will divide evenly. All right, what does that reduce to? 25 over 225. Use your calculator if you need to. Matthew, you got it? What? 1 over 9? Yep. That becomes x squared over 9. Okay. What does 9 over 225 reduce to? Y squared over 25 equals 1. That is in standard form. We're done. What's the center of that one? 0, 0. Nothing's being added or subtracted to the x or the y. Okay, so that's in standard form. All right, let's look at the next one. A little more complicated because now I have an x term. So can you guess what I'm going to do? Complete the square. Complete the square. Complete a square. That's right, Kaylee. Good job. All right, so I'm going to leave anything with a variable on the left. I'm going to leave any number on the right. So it's set up perfectly. I'm going to group the x's, group the y's, which I only have a y squared. Now, one extra step compared to what we did yesterday. See how everything in here has a factor of 4? I'm going to bring out that 4. So I'm going to bring out a 4. X squared plus 6x, now I'm going to leave some space for that funky little step, plus y squared equals 28. Okay, so funky little step we did yesterday. Take the 6, divide it by 2, that's 3, and I square it to get 9. That's exactly what we did yesterday. I'm going to put a plus 9 here, but wait, don't put a plus 9 on the right. How much did I really change the left by? Not 9, but, Charles, you just saw it, what? 36. Because that 9 in the parentheses gets multiplied by the 4 also. So to keep things equal, I'm going to add 36 to the right, because of the 4 times 9. Okay, but the rest will be just like yesterday. I'm going to have that 4 out front. It's just going to hang out there. What are the factors of this? This is a perfect square trinomial. What would my factors be? X plus 3, x plus 3. I'm just going to write x plus 3 squared plus y squared equals, okay, let's add that up, 64. Okay, one more step. I don't want a 64 over there, I want a 1. So I'm going to divide everything by 64. Okay, 4 over 64 reduces to what? 1 over 8. 1 over, ooh, be careful.
1 over
16. So I'm going to have x plus 3, oops, got to put that x in there, over 16. Okay, this next one, it doesn't reduce. Like, there's no number up top, so it's going to stay y squared over 64 equals 1. And that is my standard form. Question, would this one be vertical or horizontal? Vertical, because the biggest denominator is under y. All right, let's do this one. Let's see how many more. I planned on going through this next page, but I don't know that we'll get there. Yeah, we may have to do eccentricity on a Monday. Whew. Okay, we're not going to do every single problem in these notes. We'll skip around. All right, let's do this one, and we will call this our last example today, okay? All right, I'm going to group x's. 9x squared minus 36x. I'm going to group all the y's. Y squared plus 10y. And any numbers, I'm going to move them over to the right. Very similar to what we did yesterday. Okay, but with ellipse, I have to be careful and look for these common factors. In the x parentheses, everything can have a 9 divided out of it. So I'm going to factor out that 9. That becomes a 4x. Leave your space. There's nothing to factor out of the y's. So all we have to do is leave some space. Like that. Okay, now if you can do this little funky step in your head, then go right ahead. But just be careful. Negative 4 divided by 2 is negative 2. When I square it, I get a positive 4. But what am I going to add to the right? 36, because that 9 times 4 was really adding 36 to the left. Okay, I'm going to take half of 10. 5 squared is 25. But I didn't factor a number out of these, so I really did just add 25. So I add 25 to the right. Okie dokie, I have a 9. Can you tell me what the factors would be here? X minus 2. So if you remember yesterday, I said whatever you squared here, that's what's going to go in your factor. I squared a negative 2, so I need a negative 2 in the parentheses. Okay. Factors here would be what? Y plus 5 squared. And let's add up that right-hand side. Let's see, that's 61 minus 52, 9. Divide everything by 9 and we'll be done. Okay, so those just totally cancel. So what's going to be under the x minus 2's? Just a 1. And I guess you don't have to put the 1 there. I usually do, just so that there is a fraction there. Nothing to reduce, so I still just have a 9 under the y plus 5 squared equals 1. Okay? I like completed square. It's so systematic. Like, you do this, next you do this, next you do this. Okay, so we will not be stopping at the end of that page. We'll have to start here on Monday. And let me give you your homework sheet. We are not doing every single problem on here, so let me get these out and then I'll tell you which ones we're doing. A little more involved in circles, aren't they? Okay, let's see. All right, so these are the ones I want you to do for homework. I want you to do, let's see, let's do a vertical one on the front. Pick out a vertical one for me. Number 3 is vertical, and 2. Which one's easier? 2, why? Perfect squares, let's do 2. It's the weekend. All right, 1 and 4 are horizontal, but which one's easier? Number 1, because you got perfect squares, so we're going to do 1 and 2. All right, flip that paper over. And, 6, 8, 10, or 5, 7, 9. What do you want? And I don't really think these are any easier or harder than others. We'll stick with odds. How about that? Today's the 13th. That's an odd day. Just, it is Friday the 13th. Don't do 11, 12, or 13 at the bottom. We'll have to pick those up on Monday. Okay, so that gives you 5 problems. 1 and 2, 5, 7, and 9. Got it? All righty. None at the bottom.